So first thing we're going to look at is limits that equal infinity or limits that equal negative infinity. So we're going to start with the simple function, the function f of x equals 1 over x minus 2, which has a vertical asymptote at x equals 2. So if we look at our graph of 1 over x minus 2, and we approach from the left-hand side towards that vertical asymptote, so if we look at the limit as x approaches 2 from the left, our function is going down towards negative infinity. Okay? And if we look as we approach 2 from the right-hand side, our function should be going up towards positive infinity. Everybody agree with that?
Yes.
Yeah, all right, good. So anytime we're looking at vertical asymptotes, the answer to what is the limit as x approaches that asymptote from either the left-hand side or the right-hand side, our result should always be either a positive infinity or a negative infinity. So that's important, but the other important part of this is that we need to recognize that technically these limits don't actually exist. A limit towards infinity or negative infinity doesn't actually exist. It has to be a real number for the limit to exist. So, sorry, my son was talking to me for a second there. So we use the answer of infinity or negative infinity to give us a general idea of what the graph is doing, how the function behaves at those points or as we get close to those points. But in reality, the limit doesn't exist. So we'll give our answers as infinity or negative infinity, but on a multiple choice test, you might see, that the limit equals infinity, and that might be an answer choice, or the answer choice might be does not exist. They won't give you both of those, but the College Board people, when they write the AP test, might make the answer choice either one. I've seen them do both, so kind of need to be aware of both. Any questions so far? Nope. All right. So we've got 3 different cases. One case is that the limit as you approach the asymptote from the left and the limit as you approach the asymptote from the right might both be the same, right? In this case, both of them are infinity. Do you guys agree with that?
Yes.
Yep. And we could then say that the limit as x approaches -1 of this function is infinity. They could both be approaching negative infinity. And we could say that the limit is negative infinity as we approach 3 of this function. Or one might be approaching negative infinity and the other might be approaching positive infinity. It just sort of depends on the nature of the function that we're looking at. But all of those are possible. But remember that technically none of those limits actually exist, right? Right. All right. Good. So let's move on and see if we can find the value of some of these limits at the asymptotes without actually looking at the graphs. That's kind of the whole point of this. We'd like to know how the function behaves if we don't actually know exactly what the graph looks like. So where's the vertical asymptote of f of x equals 1 over x minus 4 to the 3rd power?
4.
Right, exactly. It's at x equals 4. So we are going to look at the limit as x approaches 4, and we're going to do it from the left and from the right. You guys have a preference on which one we do first?
The left.
The left, all right. We're going to look at the limit as x approaches 4 from the left of f of x. So what we're going to do is we're going to pick a number very, very close to 4, but on the left side of 4. So what's something like 3.9999999 and so on, right? If we plug in something like that into the denominator here where our x is, what do we end up with inside the parentheses? We end up with a very small number, right? Would you agree? 3.9999999 minus 4 is very small. It's also very small and very negative, isn't it? It's a small negative number. And then we're going to cube it, which is going to give us what?
A negative denominator.
A very small negative number still. And if I take 1 and divide it by a very small negative number, what do I get?
Negative infinity?
A negative infinity, exactly. So we know that as this function approaches x equals 4 from the left-hand side, it's hitting that vertical asymptote and it's going down towards negative infinity. So then we're going to want to look at what's happening as we approach from the right-hand side. And as we approach from the right-hand side, well, that's like 4.000001. And if we subtract 4 from that, we end up with a very small positive, right? Being cubed. And if you take a small positive and cube it, you get an even smaller positive. And 1 over a very small positive is positive infinity. So from the right-hand side of 4, as it approaches that asymptote, it's going up towards positive infinity. Everybody good with that?
Yes.
All right, cool. Let's do another one. Well, actually, let's think about this first real quick. What's the limit as x approaches 4? What can we say about that?
Does not exist.
Yeah, that one we'd have to say doesn't exist because from the left it's negative and from the right it's positive. They're not approaching the same infinity. If they were both approaching positive infinity or if they were both approaching negative infinity, we could say that the limit as x approached 4 was positive or was negative infinity, but they're not the same, so we can't. Good? All right. Why don't you guys try and do this one on your own? What's the vertical asymptote going to be? Yep, should be at x equals 2. So as you're doing your limits, you're going to look for the limit as x approaches 2 from the left of f of x, and you're going to look for the limit as x approaches 2 from the right of f of x. So take a second and see if you can come up with what those two are on your own. So from the left-hand side, like 1.99999 minus the 2, what does that give you? It gives you a small negative, which we are then squaring, which gives us a small
Positive number.
positive, giving us infinity here. And likewise, over here, when we do the 2 from the right, it gives us a small positive. And when we take that small positive and square it, we get a small positive, giving us, once again, infinity. So we could say that the limit as x approaches 2 of this function is infinity because from both sides, from the left and from the right, they're both approaching infinity. Does that make sense?
Yep.
All right, cool. What about this one? This one should have 2 different vertical asymptotes, I think. How do we find those 2 different vertical asymptotes?
Factoring.
Factor it out. All right. So what does that denominator factor to?
X minus 3 times x minus 1.
X minus 3, x minus 1, telling us that the 2 vertical asymptotes are what? X equals
3.
and x equals 1, right? Everybody good with that part?
Yep.
All right, cool. So what do you guys want to do first, 3 or 1?
1.
All right, let's look at the limit as x approaches 1 from the left of f of x. So first thing we're going to do is we're going to plug it into the numerator, right? We plug that into the numerator. What do we get?
About 4.
About 4. We'll just call it 4, close enough to 4. And then in the denominator, we're going to end up with a -2, almost a -2. And 1 from the left is 0.99999999999 minus the 1 is a very small positive or negative?
Negative.
Negative. So now we've got a positive in the numerator, 2 negatives in the denominator, which is going to cancel out to make a positive. And one of those things in the denominator is exceptionally small. So what should we end up with here?
Positive infinity.
Positive infinity, exactly. Everybody good with that? Okay. As we approach 1 from the right, is that 4 going to change?
No.
Nope. What about the -2?
It's not going to change either. I'm not sure.
Nope, it shouldn't, right? Because 1, I mean, whether I'm approaching 1 from the left or from the right, I'm still basically at 1 and 1 minus 3, or basically 1 minus 3 is still pretty much -2, right? So that won't change. The only thing that's going to change is that instead of having a small positive down there, we're going to have a small, instead of having a small negative, we're going to have a small positive, which is going to make the entire denominator a negative, very small negative, which is going to give us negative infinity. Good or no?
Good.
Okay, and so what's the limit as x approaches 1, the two-sided limit of f of x?
It doesn't exist.
Does not exist. All right, good. What if we do x equals 3? We want to do that from the left or from the right? How about left first? What do we end up with in the numerator? Positive 12. And then as we approach 3 from the left, x minus 3 is a very small what?
Small negative.
Small negative. And the other one, the 3 minus the 1 is just going to give us a positive 2, right? So what do we end up with here? We end up with a negative infinity. And as we go from the right-hand side, nothing changes except that small negative becomes a small positive, and we get positive infinity. And the limit as x approaches 3 of f of x then also does not exist. Everybody good with that? Any questions, any issues? That's about as in-depth and complicated as it gets with vertical asymptotes and limits. So if you can do that, you can do anything I should ask about vertical asymptotes. All right, let's move forward then. Let's look at the function 2 plus 1 over x, and we're going to look at the limit as x approaches infinity. So rather than getting infinity as a result for our limits, we're going to look at what happens as the x values get exceptionally large. We're also going to look at the limits as x approach negative infinity eventually. So we're going to look at what happens as the x values get to become very large negatives as well. Okay. So what happens to this function, 2 plus 1 over x, as we put in very large values of x? What happens to 1 over x?
It approaches 0.
1 over x approaches 0, exactly. And so this thing, this limit, as x approaches infinity, just becomes 2, because as x approaches infinity, 2 is just 2. So what does that mean for this function?
That its end behavior will like get closer and closer to 2 when you look at it.
Yep, exactly. If in behavior, as we get closer and closer to x equals infinity, as x gets very large, the in behavior is it gets close to 2, which is, what do we call that? It's a
Horizontal asymptote.
Yep, that's a horizontal asymptote. So this is telling us that we've got a horizontal asymptote of y equals 2. Okay? As our x values increase without bound, our y values get very, very close to 2. Now, we looked at the limit as x approaches positive infinity, which only tells us that this is a horizontal asymptote of y equals 2 to the right, because we didn't look to the left. We only looked to the right. It could be different going towards the left. How do you think we'll figure it out to the left? Using a limit as x approaches what?
Negative infinity.
Negative infinity, exactly. So as x goes towards negative infinity, what happens to the 1 over x? That 1 over x should still be going towards 0, shouldn't it? And we should end up with a horizontal asymptote of y equals 2 to the left. And if we look at our graph again, you should be able to see that that's the case, right? As we go towards the left, towards negative infinity, our function's approaching y equals 2 as well. Everybody see that? Any questions on that? Any problems with that? Okay. So last year, you probably learned some rules about horizontal asymptotes. Does that sound familiar? Specifically for rational functions.
Yeah, we did.
You did. Okay, good. Anybody remember any of those rules?
Isn't it like something from the top divided by something from the bottom or something?
Something like that. All right, doesn't sound like you guys remember those rules very well at the moment. So what we're going to do is we're going to prove each of those rules that you learned about last year that you seem to have forgotten. Don't worry, it'll only take like 15 minutes. Hopefully, not even that. So here's a rational function. Remember what I've got written below. Here's a rational function, 2x squared minus 5 over 3x squared plus x plus 2. What's the horizontal asymptote? Anybody remember? Now that you've got one sitting in front of you that you're looking at.
Negative 5 over 2?
No. Close enough.
Thirds. It'd be 2/3.
2/3. Yeah, it's going to be 2/3. Right. So you divide the constants. What you need to do is if the degree of the numerator and the degree of the denominator are the same, which they are, squared and squared, take the leading coefficients and divide them. So this one should have a horizontal asymptote of y equals 2/3. But we're going to prove that that's true. We're going to show why that's true. So what we're going to do is we're going to find the highest degree. The highest degree is 2. So we're going to divide every piece of both the numerator and the denominator by x squared. So that's what I've done here. The limit as x approaches infinity of 2x squared minus 5 over x squared all over 3x squared plus x plus 2 over x squared. And what does that do? X squared over x squared gives us what? What's 2x squared divided by x squared?
2.
2, all right. And what is 5 divided by x squared? It's just 5 divided by x squared, right? And in the denominator, 3x squared divided by the x squared is 3. The x divided by the x squared is 1 over x. And the 2 divided by x squared is 2 over x squared. Everybody good with that? As x goes towards infinity,
Learning.
what is 5 over x squared?
Approaches 0.
It goes towards 0, right? 5 divided by x squared goes towards 0. What about 1 over x as x goes towards infinity?
Also approaching 0.
Also goes to 0, and the 2 over x squared also goes to 0. As x goes towards infinity, 2 is just 2, right? And 3 is just 3. So we end up with 2/3. A horizontal asymptote of y equals 2/3. Only to the right, because we did the limit as x approaches infinity. Now, had we gone through and done positive or negative infinity, if we'd done either one of those, suppose we did the negative. If x is negative infinity, is 5 over x squared still 0?
Yep.
Yep, and so is 1 over x, and so is 2 over x squared. And if x is going towards negative infinity, 2 is still 2, right? And 3 is still 3. So either way, to the left or to the right, we should get a horizontal asymptote of y equals 2/3. If you're sitting there on the AP test and they ask you to justify horizontal asymptotes using limits, you need to fully write out and show both positive infinity and negative infinity. Even though for any rational function, so a polynomial over a polynomial, any rational function, if it has a horizontal asymptote to the right, it has the same one to the left. Okay. There are many other functions, though, where they are different to the right and to the left. We'll look at some of those today also. All right, so the rule you learned last year was the case of degree of the numerator and degree of the denominator are the same, divide the leading coefficients. This is why it works. Let's look at what happens when the degree of the numerator is less than the degree of the denominator. So we're going to do the same process. We're going to divide everything by the highest power. So what's the highest power we've got here?
4.
Yep, 4. So we're gonna divide everything by x to the 4th. And we're going to do a limit as x approaches either positive or negative infinity of 2x squared minus 5 all over x to the 4th over 3x to the 4th plus x plus 2 all divided by x to the 4th. Everybody good with that start? Everybody good or no?
Okay.
Okay. What does the 2x squared over the x to the 4th become?
2 over x squared.
Good. And then minus 5 over x to the 4th. All over down here, we've got 3 plus 1 over x cubed plus 2 over x to the 4th. And so everything in the numerator, as x goes towards either positive or negative infinity, is going to trend towards what?
0.
0. And everything in the denominator, except that 3, is going to do the same. We end up with 0 over 3, or just 0. and we have a horizontal asymptote both to the right and to the left of y equals 0. Good or no?
Good.
All right. And so that was the rule that you learned last year, that if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is always 0. That'll always happen because you'll be left with one constant in the denominator, one non-zero constant in the denominator, but everything in the numerator will cancel out to become 0. And if we flip it around the other way, so if the degree of the numerator is more than the degree of the denominator, what do you think is going to happen?
Would it end up undefined?
It's going to end up undefined, right? You're going to think of the case of just the reciprocal of this. We'd have the reciprocal of this, which would be 3 over 0, which is undefined, which means there won't be a horizontal asymptote. So we'll look at one of these real quick. The highest degree of this rational function is 3. And so we're going to divide everything by x to the third. And in fact, we'll just do that all in one step. 2x cubed divided by x cubed is 2. And then minus 5 over x cubed over, and then 3x squared divided by an x cubed is going to be 3 over x plus 1 over x squared plus 2 over x cubed. And everything but that 2 is going to tend towards 0, giving us 2 over 0, showing us that this has no horizontal asymptote in either direction. Everybody good with that? Any questions, any issues on that? All right, well then, let's look at one where it gets a little more complicated. Let's find the horizontal asymptotes for root 9x squared plus 2 over 4x plus 3. Let's do the limit as x approaches infinity first. So as x goes towards infinity, is this plus 2 very significant in comparison to an x squared, even if that x squared is inside of a square root?
No.
No, right? The top is infinity, isn't it? Do you guys agree with that? Top is infinity. And that plus 2 doesn't do much to that infinity, because even the root 9x squared part would be infinity. If I add 2 to that, it's still infinity. And what about the 4x plus 3? The 4x is infinity, right? And the plus 3 doesn't add much to it. Infinity plus 3 is still just infinity. In fact, I should mention, I didn't mention this on any of the last 3, but if we plugged in infinity at the beginning, each of these is just infinity over infinity. And that form, infinity over infinity, is another indeterminate form that you want to be aware of. We'll talk more about it later on this year, but infinity over infinity is another form to be aware of that's indeterminate. So what we're going to do is we're going to basically say that this plus 2 and this plus 3 are insignificant, and we're only going to deal with the root 9x squared and the 4x piece. What's the square root of 9x squared?
3x.
Close.
Positive and negative 3x?
Sort of. Closer, I guess, but not quite. Sometime long ago, back when you were in like algebra 1 or integrated 1 or something, they told you this. The square root of x squared, at least I hope they told you this, is equal to the absolute value of x. Right? The square root, unless it's within an equation, means the principal square root. Unless I have a negative in front of it, okay, it means the positive square root of it, which means that whatever I get out has to be positive. Does x have to be positive?
Hypothetically, I mean, there's I, right? So it kind of.
Well, we're not going to deal with imaginary numbers, in fact, really at all this year. But what I'm asking is, can I plug any value of x into this root x squared?
No.
Yeah.
I could put a negative or a positive into that, right? Suppose I put in 2. Let's say x equals 2. Well, I have the square root of 2 squared, right? Square root of 2 squared, that's 4. Square root of 4 is 2, right? But if I look at what happens when x equals negative 2, I'm looking at the square root of negative 2 squared. Well, negative 2 squared is 4, and the square root of 4 is 2. Either way, the answer I get is 2. So I don't always get x out of this. I do get, in fact, I don't even ever get a positive or a negative x. Well, I do get a positive or a negative x out of it, but I always get this positive value, which means that it needs to be within an absolute value, because even if I put in a negative, I get out a positive, the positive version of it. Does that make sense?
Yeah.
All right. So what we're going to say is this is effectively the absolute value of 3x over 4x. Everybody okay with that or no? Hopefully so. Okay.
Yes.
So if x is going towards infinity, what can you tell me about the absolute value of 3x? Or what can you tell me about 3x? 3x is a positive number, right? Agreed? If x is going to infinity, 3x is positive?
Yeah.
Yep, because x is just a large positive number, and 3 times that is still positive. So when you take the absolute value of a positive number, what do you get? You get exactly what was inside the absolute value to begin with. You guys agree? You get 3x?
Yeah.
Okay, which becomes the limit as x approaches infinity of 3/4, because the x's can cancel, which gives you 3/4. Everybody okay with that? I equals 3/4 is our horizontal asymptote to the right. But when we go in and do this to negative infinity, the square root of 9x squared is still absolute value of 3x. 4x is still just 4x. But now, what can you tell me about the value of 3x? Regardless of the absolute value, what is 3x? 3x is what kind of number? Is it a positive number or is it a negative number?
Negative.
Negative.
3x, yeah, 3x is a negative number. And so when you take the absolute value of a negative number, you get the opposite of the thing that you started with, right? The definition of absolute value says absolute value of x equals x if x is greater than or equal to 0, and absolute value of x is equal to the opposite of x if x is less than 0, right? So if I say, what's the absolute value of -1? The answer is it's the opposite of -1. It's 1. Right? So that's effectively what we're doing here. We're saying, what's the absolute value of 3x when 3x is a negative number? Well, the absolute value of 3x, if 3x is negative, is negative 3x. It's the opposite of 3x. Does that make sense? Any questions on that? Okay. And so now we have negative 3x over 4x. The x's will cancel. And we're just left with y equals negative 3/4, which is our horizontal asymptote to the left. And I don't know why I wrote 34 instead of 3/4, but we'll fix that. Does that make sense or no? Anybody confused on that? Let's look at the graph of this on Desmos. What was it? Square root of 9x squared plus 2, I think, divided by 4x plus 3. And if we look, as x goes towards infinity, yep, we're going up to positive 3/4. But if I go towards negative infinity, right, it's approaching negative 3/4. So we have different horizontal asymptotes in different directions. Good or no?
Good.
All right, this type of question with the limit as x approaches negative infinity of the square root of something shows up quite often on the AP test. So whether it's in the pre-response or in the multiple choice, you want to be aware of this and make sure you understand this. All right, let's sort of change gears here. We're going to start talking about a new function. We're going to talk about the e to the x function and the e to the negative x function. You should all be fairly familiar with those functions, right? E to the x is our standard exponential function. So here is e to the x power. Right? As we go to the left, towards negative infinity, it approaches a horizontal asymptote of 0. But as we go towards positive infinity for x, the y's increase without bound and goes towards negative infinity, or sorry, positive infinity. If we go and look at e to the negative x, it's just a reflection of that over the y-axis. So towards infinity, there's a horizontal asymptote of y equals 0 to the right. And as we go, x goes to negative infinity, y goes to positive infinity. Everybody good with those graphs? Those look familiar. You've seen those a million times before. Hopefully so. All right, so what's the limit as x approaches infinity of e to the x?
Positive infinity?
Positive infinity, right? It's increasing without bound. It's going up, not necessarily to an asymptote up there, but it's increasing without bound, so it's infinity. What about the limit as x approaches infinity, negative infinity of e to the x?
0?
That one's 0 because that's where your horizontal asymptote to the left is. And for e to the negative x, as we go towards infinity, what is that approaching?
0.
Yep, 0, that's the horizontal asymptote to the right for that one. And as x goes to negative infinity, e to the x is increasing without bound and going towards infinity. Everybody feel comfortable with those and able to see those by going straight from the graph and thinking about what the function does? All right, I'm going to assume that's a yes. I hope so, because we're going to utilize those functions to deal with some slightly more complicated exponential functions. You probably couldn't perfectly sketch the graph of e to the 6 minus 2x minus 5x squared for me. But what you could hopefully do is you could make a substitution and get rid of that 6 minus 2x minus 5x squared and just turn this into the graph of e to the u. Because if we could turn it into the graph of e to the u, or the function e to the u, we know how that one behaves, don't we? You guys are awfully quiet today. So as x approaches infinity, what does u approach?
Infinity.
Sorry, I couldn't hear. Positive or negative infinity?
Positive.
Negative infinity, right? Because you're subtracting.
Yeah, it should be a negative infinity because we're taking the infinity and squaring it here with the x squared, and that x squared dominates the 6 and it dominates the minus 2x. This part of it sort of becomes insignificant because the x squared is more powerful than it, but it's a negative 5x squared, which means it's u is approaching negative infinity as x approaches positive infinity. So we can completely rewrite this limit as the limit as u approaches negative infinity of e to the u. And that one, we just figured out on the previous page. What does that one come out to be?
0.
0. So we know that this function, e to the 6 minus 2x minus 5x squared, has a horizontal asymptote to the right of y equals 0 because we were originally looking at the limit as x approaches infinity of this function. Any questions on that? All right. Let's see if you guys can do this one on your own real quick. Using similar process with a u substitution. How'd that go?
Good.
All right, did you do the substitution where u is equal x to the 4th minus 2x plus 1? Hopefully so. As x approaches negative infinity, then what is u approaching?
Infinity.
That's right, we should be approaching positive infinity because this time the x to the 4th is dominating the minus 2x plus 1, and you take a negative to the 4th power, you get a positive. So this is the limit as u approaches infinity of e to the u, and that should be what?
Infinity.
Infinity. Exactly. Any questions on that? All right. Same idea. See if you can apply the same rule to do this one. So what's your u substitution? U equals
2 plus x cubed.
2 plus x cubed, and as x is going to negative infinity, what is u going towards this time?
Negative infinity.
Negative infinity. So we'll rewrite this as a limit as u approaches negative infinity of e to the u, which is what? 0. Very good. Everyone good with that? I'm not sure if somebody, it sounded like somebody was trying to say something, but cut out on them. All right, let's take a look here. What's the limit as x approaches 0 from the right of e to the 1 over x? So let's do a similar substitution. Let's let u equal 1 over x. And as x approaches 0 from the right-hand side, what does u approach?
0.
Nope. If x is approaching 0 from the right, that means that this denominator is a very, very small positive number.
Positive
So I have,
infinity.
right, should be going towards positive infinity. So we're going to rewrite this as a limit as u approaches infinity of e to the u. And what should that be?
Positive infinity.
Positive
Wait, but won't it
infinity.
be smaller and smaller if you use
Uh,
higher?
Sorry, say that again?
Won't 1 over x be getting smaller and smaller?
No, because x is approaching 0 from the right. So the x values are getting very small, like 0.000000001, and 1 divided by that is a very large value.
Okay, I see.
Good. Any other questions on that one, or everybody else okay with that for now? All right. These ones look pretty easy, right? Just as easy as the ones we've been dealing with. What should we always do first? We should always just plug in that infinity value. What happens if I plug in infinity? E to the 10x is infinity, right? If x is infinity, minus an infinity, right? Plus an infinity. And then the 2e to the negative 2x is plus 0, right? And then minus a 0. Everybody agree with that? Infinity minus infinity plus infinity, plus 0 minus 0. Yes, no, maybe?
How did you get the plus 0 minus 0?
So if I plug in infinity, this is e to the negative infinity right here on the negative 2x. And so from a few slides back, we decided that e to the negative infinity was 0, right? Good or no?
Makes sense.
Okay. Cool. So the problem, though, that we have here is this infinity minus infinity plus infinity. Anytime you ever have infinity minus infinity, that is indeterminate. And so we have to deal with that in some way. So if we look at the second part of this plus 0 and this minus 0, those aren't a problem, right? It's these infinities, all these extra infinities that are a problem. So what we're going to do to get rid of those infinities is we're going to take the largest exponent, this e to the 10x, and we're going to factor out e to the 10x from all 5 pieces of what's in my function here. So we're going to look at the limit as x approaches infinity of e to the 10x times. So if I factored e to the 10x out of e to the 10x, what's left?
1.
1. And if I factor e to the 10x out of 4e to the 6x, what's left? Minus 4e to the negative 4x, right? Because this exponent plus this exponent needs to equal the exponent I started with. Do you guys agree with that factoring?
Yeah.
Makes sense.
Okay. And then what about this one? Plus 3e to the negative 9x plus 2e to the negative 12x minus 9e to the negative 25x. Good or no?
Yep.
Good.
All right, so what good was all of that is the question. Well, e to the 10x, this first part that's now been factored out, as x goes to infinity, this piece right here is infinity. And everything inside the parentheses now should all be constants. It should all be zeros except this first term. So we've got a 1 minus 0 plus 0 plus 0 minus 0. And what are we left with? We're left with infinity times 1, which is just infinity. Good or no?
Yeah. Good.
All right. Good, 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 good. Any questions on that? Nope. All right, so when we try this bottom one, where we're looking at the limit as x approaches negative infinity, what happens if I plug in negative infinity to e to the 10x? What do I get?
0.
0. And the minus 4e to the 6x is minus 0. And the plus 3e to the x is plus 0. And then the plus 2e to the negative 2x is what? Plus
infinity.
infinity. And then the last piece there is a minus infinity. So once again, we've got this same problem with parts of it being infinity minus infinity, which is indeterminate. So what do you think we should do with it this time to deal with that? Last time it was the positive exponents that were an issue. This time it's the negative exponents. So the first time we factored out the largest positive. What about factoring out the largest negative this time? Take out e to the negative 15x. What's that going to leave us with? If I take e to the negative 15x out of e to the 10x, what does that leave me with? E to the
25.
25x, right? Because this exponent plus this has to, or sorry, this exponent plus the 25 has to equal 10. So then what about the next one? Minus 4e to the negative 15 plus what gives us 6x? 21, right? And this next one should be plus 3e to the 16x. And the next one should be plus 2e to the 13x. And this last one should be minus what?
9.
Minus 9. Good. And now if I plug in negative infinity for e to the negative 15x, what do I get?
Infinity.
I get infinity. And everything else inside these parentheses here is 0 minus 0 plus 0 plus 0, and then minus that 9. And so if I have 0 minus 0 plus 0 plus 0 minus 9, I have a negative 9 times infinity. And what's a negative 9 times infinity? Should just be negative infinity, right? 9 infinities is still infinity. Any questions on that, or is that good?
That makes sense.
All right, excellent. All right, well, we're almost done. We got two more pages here, 3 problems to do. We're gonna change gears slightly and look at some logarithmic functions rather than some exponential functions. So before we do that, we're just gonna remind ourselves, what does natural log's graph look like? As we go towards infinity, it increases slowly, but without bound, right? As we go towards infinity, natural log goes towards infinity. The x goes to infinity, the y's also go towards infinity. And as we go towards 0 from the right-hand side, natural log goes down towards negative infinity. Can we approach 0 from both sides? Can we get a limit as x approaches 0 of natural log of x?
It doesn't exist.
It doesn't exist because there's no open interval to the left of x equals 0 on the natural log function. We can only approach 0 from the right. Okay? We can't approach negative infinity because there's nothing over here, but as we approach infinity, natural log also goes to infinity. Everybody good with the natural log graph and how it is affected by limits there? All right. So we're going to do the same process as we did with the e's, and we're going to make a u substitution. We're going to let u equal 4x squared plus 5x minus 2. And we're going to break this down so that it just becomes the base natural log function. Now it's just natural log of u. So we need to say as x goes to infinity, what does u go towards? So as x goes towards infinity, this 4x squared dominates the 5x minus 2. And if we're squaring infinity and multiplying it by 4, that's still going to just be infinity. So this becomes the limit as u approaches infinity of natural log of u. And as we just said, what does that equal?
Infinity.
Should be what? Sorry, I couldn't hear you.
I think it's infinity.
You think correctly. It is infinity, right? Looking at that graph, as x goes towards infinity, even though it's not doing it very quickly, the natural log function increases forever. It goes up and up and up and up, right? It doesn't, it's hard to see it, but it does it. You know, it takes forever, but it does it. All right, what about this bottom one? We're going to do the same substitution. Let u equal 4x squared plus 5x minus 2. And as x goes towards negative infinity, what is u approaching?
Positive infinity because it's
Positive. Yep, because what?
because it's getting squared.
Right, because the 4x squared dominates the 5x minus 2. We square the negative, makes it positive. Multiply it by 4, stays positive, goes towards infinity. So this limit actually ends up boiling down to the exact same thing as the one above did. The limit as u approaches infinity of natural log of u, which is still infinity. And you'll probably note as the year goes on that my limits and my natural logs look awfully similar, but if it just kind of trails on forever, it's a limit, and if it doesn't, then it's a natural log. Everyone good? We got one problem left to do, and then we're going to be done a couple minutes early. Unlike second period, we went over in second period. Okay. We're going to look at the limit as x approaches negative infinity of natural log of 1 over x to the 4th minus 8x. So what do you think we should do our u substitution with?
X to the 4th minus 8x.
Just the x to the 4th minus 8x, or do you want to do the full fraction?
Oh, probably the full thing.
Okay, we could do it either way, but I think using the full fraction allows us to turn it into just that simple base natural log u function that we know how it behaves. So we're going to be looking at a limit as u approaches something, we'll figure out what that is in just a second, of natural log of u. So as x goes towards negative infinity, what is u going towards? Well, the denominator of this fraction, what dominates that?
X to the 4th.
Right, the x to the fourth does. And so the minus 8x is sort of insignificant. And negative infinity to the fourth power is positive infinity. So what we've got down here is we've got a 1 divided by a positive infinity. And we know that 1 divided by infinity is what?
0.
A 0. But we want to be extra careful and as specific as possible. This 1 is positive and this infinity is positive. So as we're doing this division and we approach 0, from which side are we always approaching from?
The top, it's like, or the positive side.
From the positive side, from the right. Right? If one of these were a negative, then we'd be approaching 0 from the left-hand side. But they're not. They're both positive, so we're approaching 0 from the right. Does everybody see that? Okay. And so what's the limit as you approach a 0 from the right of natural log of u?
Isn't it 1?
No. If we go back and look at our graph,
Isn't it negative infinity?
it's negative infinity, right? As we approach 0 from the right, our function is going down towards negative infinity. So this is negative infinity. And that's why it's so important that we had this approaching from the right-hand side, because if we're approaching from the left-hand side, as we said before, we can't do that. We can't approach 0 from the left-hand side because there's no function. And we can't just make it 0 because there's no open interval on both sides of 0 for us to go down towards negative infinity. Does that make sense to everybody? All right, that should be it for today. So what I did was I posted up another assignment for you guys. It's due next Friday. It's got everything that we have learned so far in it, plus a couple things that we're going to talk about at the beginning of next week. So that'll be due at the end of the week on Friday.